Hello learners! Welcome again to our YouTube channel. Our topic is about acoustical control in buildings. May you listen and learn as we branch out and dig deeper into this lesson. Let's begin by defining acoustics. According to the Merriam-Webster Dictionary, acoustics is a science that deals with the production, control, transmission, reception, and effects of sound. Building acoustics is important for the consideration of factors that affect the occupants and the functionality of the building, and it must be studied in order for the sounds created within spaces to not have negative effects. Sound. Sound is caused by the vibrations which transmit through a medium such as air and reach the ear or any receiver that can detect it. Sound intensity is measured in decibels, or D-B. Sound pitch is measured in hertz, Hz. Sound is typically characterized by three characteristics. Frequency or pitch is the measurement of the tone or musical note of a sound. Next is wavelength. The wavelength of a sound wave is the distance between the start and end of a sound wave cycle, or the distance between two successive sound wave pressure peaks. The last characteristic is amplitude, or the loudness. The amplitude of a sound wave is visually its height from bottom to top, but it is in fact indicative of the strength of the energy in that wave. Sound transmission class, or STC, and noise reduction coefficient, or NRC. What is sound transmission? Well, sound transmission is defined as a common acoustic issue, for it can be both airborne or structure-borne vibration. A sound becomes a noise when it reaches a space where it is unwanted. Noise from the outside can transmit through the exterior structure of the building. Noise from the interior surroundings can transmit from one room within a building to its adjacent place or space. Lastly, sound transmission causes noise control and privacy issues. Sound insulation. Sound insulation reduces the transmission of sound. Transmission loss is a measurement of a partition's ability to block sound at a given frequency, or the number of decibels that sound of a given frequency is reduced in passing through a partition. The sound transmission class, or STC, which is determined by ASTM E90, is a single number rating of a material's or an assembly's ability to resist airborne sound transfer at the frequencies 125 to 4000 Hz. The sound transmission class is highly dependent on the construction of the partition. A partition's STC can be increased by, number 1, adding mass. The weight or thickness of a partition is the major factor in its ability to block sound. This simply means that more weight or thickness, the more capability for it to block the sound. Number 2, it is the increasing or adding airspace. An airspace within a partition can also help to increase sound isolation. Lastly, for number 3, adding absorptive material in the partition. Sound absorptive material can be installed inside of the partition's airspace to further increase its STC rating. In this slide, we will show you some sample wall assemblies. So the first one is 3 5/8 inches metal studs and 5/8 inches gypsum with 2 layers in total and no isolation. The estimated STC rating is 38 to 40, and this is how the wall assembly looks like. Next is 3 and 5/8 inches metal studs with 5/8 inches gypsum with 2 layers in total, but it has batt insulation. The estimated STC rating is 43 to 44, and this is how it looks like. Insulation will noticeably improve the STC rating of an assembly. The next sample is 2x4 stud with 5/8 inches gyp and 2 layers in total, and also have a batt insulation. The estimated STC rating is in 34 to 39, and this is how it looks like. Next is 3 and 5/8 inches metal studs and 5/8 inches gyp, and it has 2 layers in total with batt insulation. It has a rating of 43 to 44, and the wall assembly looks like this. Metal stud walls perform better than wood stud walls. Note that this is only applies to single stud assemblies. For double stud assemblies, there is virtually no difference. And for the next sample, we have 2x4 stud with 5/8 inches gyp, and it has 2 layers in total, and also it has batt insulation. For its rating, it has 34 to 39, and the wall assembly looks like this. Next is 2x4 again, a stud with 2x4 and 5/8 inches gyp with 4 layers in total this time, but it has a batt insulation. And also, it has an estimated STC rating of 43 to 45, and this is how it looks like. Adding additional layers of drywall can improve the STC rating of an assembly. The next slide shows us a sample of 2x4 studs with 5/8 inch gyp and 4 layers in total, with batt insulation with rating of 44 to 45, and this is the wall assembly. Next is 2x4 stud with 5/8 inches gyp and 2 layers in total with batt insulation with a rating of 56 to 59. This is how it looks like. Thirdly is 2x4 stud with 5/8 inches gyp with 3 layers in total and batt insulation with a rating of 59 to 60. This is how it looks like. 2x4 studs and 5/8 inches gyp with 4 layers in total with batt insulation with a rating of 58 to 63. The wall assembly looks like this. Drywall between double studs can dramatically reduce the STC rating of an assembly.
General rules of thumb for controlling noise between spaces. Number 1. A wall must extend to the structural deck in order to achieve optimal isolation. Walls extending only to a drop ceiling will result in inadequate isolation. Number 2. Sound will travel through the weakest structural elements, which many times are doors, windows, or electrical outlets. Number 3. When the mass of a barrier is doubled, the isolation quality or STC rating increases by approximately 5 decibel, which is clearly noticeable. Number 4. Installing insulation within a wall or floor or ceiling cavity will improve the STC rating by about 4 to 6 decibel, which is clearly noticeable. Number 5. Oftentimes, specialty insulations do not perform any better than standard batt insulation. Number 6. Metal studs perform better than wood studs. Staggering the studs or using dual studs can provide a substantial increase in isolation. Number 7. Increasing airspace in a wall or window assembly will improve isolation. Recommended ratings. In general, loud speech can be understood fairly well through an STC 30 wall, but should not be audible through an STC 60 wall. An STC of 50 is a common building standard and blocks approximately 50 decibel from transmitting through the partition. However, occupants could still be subject to awareness if not understanding of loud speech. Constructions with a higher STC should be specified in sensitive areas where sound transmission is a concern. The UBC, or the Uniform Building Code, contains requirements for sound isolation for dwelling units in Group R occupancies, including hotels, motels, apartments, condominiums, monasteries, and convents. UBC requirements for walls. A sound transmission class or STC rating of 50 if tested in laboratory or 45 if tested in the field. UBC requirements for floor or ceiling assemblies. STC ratings of 50 if tested in a laboratory or 45 if tested in the field. The field test evaluates the dwelling's actual constructions and includes all sound paths. Noise Reduction Coefficient, or NRC. Noise reduction coefficient is a single number index determined in a lab test and used for rating how absorptive a particular material is. NRC rating ranges from 0.00, which is perfectly reflective, to 1.00, which is perfectly absorptive, and it can be viewed as a percentage for how well a material absorbs sound. Sound absorption. Sound absorption is the loss of sound energy due to the sound waves being absorbed by materials capable of doing such, while sounds which are not absorbed are reflected back. The NRC rating is an average of how absorptive a material is at 4 frequencies, such as 250, 500, 1000, and 2000 Hz. This rating is appropriate for assessing how well a material absorbs sound within the speech frequencies, but can be inadequate for sound generated by music, mechanical equipment, or other low-frequency sounds. The NRC is based on lab test because the lab is a near-perfect environment that is rarely duplicated in everyday applications. Some products will not test the same in the field. Certain factors, such as installation variables, are not accounted for in the lab. A product that receives high ratings in the lab may not perform as well in the field. Sound transmissions, reflections, and absorptions happen all at the same time depending on the setting. Some noise reduction coefficients, or NRC, for common building materials. Material number 1. Concrete, smooth and painted, NRC 0.00 to 0.05. Number 2. Concrete, smooth and unpainted, 0.00 to 0.20. Number 3. Concrete, block and painted, 0.05. Number 4. Concrete, block and unpainted, 0.05 to 0.35. Number 5. Cork floor tiles with 3/4 inch thick, 0.10 to 0.15. 6. Cork wall tiles with 1 inch thick, 0.30 to 0.70. Number 7. Fabric on gypsum, 0.05. Number 8. Fiberglass, 3 to 1/2 inch batt, 0.90 to 0.95. Number 9. Fiberglass, 1 inch semi-rigid, 0.50 to 0.75. Number 10. Glass, 0.05 to 0.10. Number 11. Gypsum, 0.05. Number 12. Linoleum on concrete, 0.00 to 0.05. Number 13, marble, 0.00. 14, plaster, 0.05. 15, plywood, 0.10 to 0.15. 16, rubber on concrete, 0.05. 17, seating which is occupied, 0.80 to 0.85. 18, seating unoccupied, metal, 0.30. Number 19, seating unoccupied and wood, 0.30. 20, seating unoccupied, fabric upholstered, 0.60. 21, soundboard with 1/2 inch thick, 0.20. 22, sprayed cellulose fibers, 1 inch thick on concrete, 0.50 to 0.75. 23, steel, 0.00 to 0.10. 24, wood, 0.05 to 0.15. So these ratings may not reflect the specific NRC for your particular material, depending on variables such as type, size, thickness, installation methods, and etc. It is important to remember that certain absorptive properties of materials may differ drastically based on numerous variables. For example, a concrete wall could be 0% to 35% absorptive. If available, it is always best to get the tested NRC rating from the manufacturer. It is advisable to seek an unbiased third party, such as an acoustical consultant, for NRC confirmation on a particular product and installation. So let us know the difference between NRC or noise reduction coefficient and STC or sound transmission class. NRC. NRC refers to a single number index for rating how absorptive a material is. A material with an NRC of 0.80 will absorb 80% of the sound that comes into contact with it and will reflect 20% of the sound back into the space. It is the average of the mid-frequency sound absorption coefficients of 250, 500, 1000, and 2000 Hz rounded to their nearest 5%. It gives no information as to how absorptive a material is in the low and high frequencies. On the STC, however, STC refers to a single number rating of a material's or assembly's barrier effect. A higher STC rating blocks more noise from transmitting through a partition. STC is based on performance with frequencies from 125 to 4000 Hz. STC does not take into consideration weak points, penetrations, or flanking paths. NRC and STC are completely exclusive of one another. NRC is a measurement of how well a product makes the room you are in quieter, while STC measures how well a product keeps sound from escaping the room. If you are in a noisy room like gymnasium, you want a product with a higher NRC on the walls or ceiling to make the room less noisy. If you are in a conference room where you are talking about sensitive topics that you don't want people on the other side of the wall to hear, you need a product on the wall with a high STC. Why do we need to consider acoustical control in buildings? While the systems of any structure are essential, acoustical control must also be taken into consideration, especially during the planning phase. Proper design of the building acoustics ensures that any potential problems regarding sound and noise control are addressed, such as privacy, health-related concerns, safety, and many more. A building with good aesthetics and fully functional systems but does not have good noise control may hinder its functionality. We know that noise often distracts, disturbs, or even causes confusion. There may even be instances where unwanted sounds might cause stress and anxiety, and we need to make sure that the building is comfortable for the occupants. If the occupants experience unwanted noise within a space that no acoustical consideration, additional acoustical solutions may be installed after, or it may even be a call to redesign or reconstruct the space and will cost more. So it is best to consider building acoustics as early as during the design planning phase instead of after the completion of the building.